بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Okay, so today we are going to continue with the Java collection framework. Yesterday we have introduced different type of collections, including linked list, hash set, and tree set. So what is the difference? Can you remind me what is the difference between list and set? Yes?
Set don't take same value.
Duplicate values, yes. And list? It can have duplicate values. Okay, yes, so this is the difference, and we have demonstrated this through one example. Okay, so yesterday we went through all the different methods of list and set. Okay, and all of them actually they implement the interface, the method of the interface collection. Okay, so we have the interface collection here, Java. Okay, we have list interface, and we have the set interface in Java. Okay. So the set method actually implements the same methods as collection. So here in the list, we do have a method that is get, that returns the value of a certain index, but you don't have the same for set. Now, okay, for set, if I want to get some particular value, I don't have like a direct method that going to return me the object, okay, at a certain index. So I need to do a different way and to go through the element one by one. Okay, so one of the ways to do it is to do a for loop. Okay, so we can do a for loop for a set. For example, for every integer and for every integer n in, we have here hash set, int hash set. Okay, we can print the value of n, or we can make here a index I equals 0. Let me make with %f, %d equal %. So here I will have I, and then I will have, okay, this is one of the ways. And I make /n here. So these are different values that are stored. So the second way, which is also the most common, is to use what we call an iterator, whatever for the list or for the set. So here you can see in collection, we have a method called iterator. Okay, so this iterator will return an object that allows you to go through all the elements one by one. It's very similar to what you know already in files. So if you want to, for example, if you want to read in a file, okay, you will create a file object, and then you do while file.hasNext, okay, and then you read one by one. So this is the same thing that we are going to do also with the iterator. So here, to create an iterator, it's an interface, okay, it equal so I need to import iterator. So it's not possible to make a new iterator. This is first thing to know, because an iterator is an interface. So this is something that cannot happen. If you want to get an iterator, so you have any kind of collection, whatever it is, set or or a list. For example, I'm going to start with the set dot iterator. Okay, so this, what's going to happen is going to return an iterator from the beginning of the list. I'm going to show you an example. Let's say iterator for hash set. We can do the same for the array list for all of them. Okay.
So
Now, it's not clear. I cannot increase more because okay, so I can do int ArrayList.iterator. I can do the same for the linked list. Okay. And I can do the same also for the tree set. Okay, this is hash set iterator. So an iterator can be applied to any kind of collection. Okay, so what happens when you do an iterator now? I'm going to show you. So imagine that you have a collection. Okay, so let's have this collection. It contains some number. Okay. So when you do an iterator, we're going to have like a pointer, okay, pointing to the first element. Okay, this is what happens. So now, if for example, I'm going to do, for example, the value, okay, the first value in a hash set. So how to get the first value in the hash set? It's very simple. I'm going to use the iterator dot next. So when I do iterator dot next, what happens is going to return the current value, that is 1, and the iterator is going to jump to the next position. Two things that will be done at the same time. So it's like the next in the file. In the file, when you read with the next int or the next line, is going to return you one line or one int or one value, then one string, and then move to the next line. Okay, so it's the same thing that happens with the iterator. So now if I do, we can check this one. Okay, so look now, the first value that we have is 1. We can, okay, so the first value in the hash set is -1. If we look at the hash set, the first value is -1. So now if I make another time next again, okay, so if I do next again, this is the second value, will be the second value now, okay, because every time is going to jump to the next position. Okay, so here, if I run, now it's 1. So I can do next until I reach the end of the set. So how to know that I reach the end of the set? Okay, in this case, we can use, okay, we can use a while loop dot has next. So dot has next is going to return a Boolean variable, Boolean value, true or false. If there is something remaining in the tree set, it's going to return true. So what we can do if the iterator has next. Okay. So I can print here. We can do also a counter. We can make I equal to 0 here. So here we're going to have what? Iterator.next. Is it clear? So every time I'm going to have printf. Okay. So we can check now. Okay, let me, I don't know, using iterator. While, I should use while, not if, okay, that's the problem. Okay, you can see now, it went through all the elements one by one. Okay, so while the iterator dot has next, okay, print iterator dot next. So what's going to happen? Every time it's going, for example, it returns the first value, then the second value. Then when it returns the second value, it moves to the third position. If I call next again, okay, returns here -1 and move next, then move next again. So when it comes here, has next will return false because there is no next. Okay, that's why it's going to return the value and then leaves the loop. واضح? Okay. Sorry?
If I wanted to get certain value, like index 3, I should use a counter as the value for loop.
If you want to get certain value, yes, you can make a counter like this. When you reach certain value, you return it. But it's not common because in the set usually you go through all the elements, but you can do it. Okay, so this is about the iterator, okay? And the iterator is for any collection, list and set both together. Okay? What I did for set, I can do it for list. I can do it for linked list. Okay? The same. Now I can do the same. I take linked list here. Okay? Of course, I need to create an iterator for that. IT linked list. Okay, yes. Okay, so this is the iterator of the linked list. We can do exactly the same thing. For okay. Okay, now we have all the values for the int linked list here shown. Okay, so the iterator allows you only to go into one direction, that is forward. You cannot go backward. Okay? And for the set here, okay, we do have the method iterator. Where it is? Yeah, here. In the list, we have another method that is called ListIterator. Okay, and this iterator allows you to go forward and backward. So you can do next and you can do previous. And this is only possible for the list. and not possible for the set. Okay, so if you want to create a list iterator, if you want to move forward and backward, in this case you have to create a list iterator. If you have a set, you can only create an iterator that allows you to move forward to go through all the elements. Okay, so now let's make an example about list iterator. So list iterator here, you have an iterator, and then if you make dot next is going to move forward. If you do previous, for example, if I am here and I do dot previous, it's going to return 3 and then move backward 1 step. Okay, and instead of having has next, we have also has previous. So when it comes to the first element, has previous is going to return false. This is to know that we reached the start of the list. Okay, so we have has next allows you to know the end of the list, and has previous allows you to know the start of the list. So let's do an example about list iterator, and this is only valid for list, and it's called list iterator, so we cannot do it for set. I'm going to show you if we want to make it for set, the compiler will not accept that. Okay, so to create a list iterator, the same thing. We have the interface list iterator. It's an interface, we cannot make new. Okay, let's IT. I'm going to make it for ArrayList. I'm going to call it LIT. Equal. Okay, I have to import first the list iterator here, and then I will take the int ArrayList dot list iterator. So here is going to do the same thing as an iterator. It's going to do the same thing as if I do it like this, it's going to return an iterator that starts from the beginning. Okay, and I can do the same also for the linked list. Okay, for the linked list, I can do the same. List iterator, that's going to be fine. Now, if you want to do the same for a set, whatever it is, tree set or hash set. Okay, so let me bring this one. It's not going to be accepted. Okay, so this is an error. We cannot do a list iterator for a set. It's called list. Okay, it doesn't apply for set. Okay, one more thing that yes, we can not yes. Yeah. So one feature that that is provided to you by the list iterator, you can specify from which position you want to start. For example, I want to start from the end. Okay, I want to start from the end. I can do list iterator dot size and here -1. So this will start the iterator from here. You can also specify at any position, at index 2. Okay, so 0, 1, 2. You can start the iterator from position 2. So with the list iterator, and this is not possible with the iterator, you can specify from which position here. Look, you have list iterator, like with no parameter. Okay, and this one starts from the beginning, from the start of the list. And you have a list iterator with the index, allows you to specify where, from which position you want to start. Okay, so now for example here, we can do same thing, using a list iterator for the linked list. Okay, so here, for example, I would like to go to the previous value, so I can use, if it has previous, okay, and then dot previous. I can do the dot next, and has next is possible, but now I'm going to show you that also we can go backward. Okay, so here we start from index 2, and I would like to return all the elements starting from 2 until the start. Okay, so if I execute this one, so LIT, this is for linked list iterator. Okay, now if I run, look, using a list iterator, it returns the last values. I start from index 2, so it returns index 1. It doesn't return index 2, previous. So when you are here, so we have 1, 4, 19, minus 1, and so on. So when I start at position 2, dot previous is 4. Okay, and this is now dot previous. And here, then 1. Father, it comes to, yeah. Okay, I forget to make. Okay, I can do the same also for the array list. Okay, so this is for the array list. I can also do has previous. Okay, it will start from the end. So this is going to print into the reverse order. In the reverse order. This is for array list in reverse order. Okay. So as you can see here, the int array list, it contains these values. I think we have to start from the size, not the size minus 1. Yes. Look now, 4, minus 1, 5, 4. And this is the opposite order because the int array list, it starts like this. So 4, minus 1, 5, 4, and so on. So it makes it in the reverse order. Okay, so now this is all about array list or an iterator and a list iterator. Okay, so to summarize, in order to go through all the elements, we can use an iterator, okay, or we can use also a for loop for each statement loop. So an iterator applies for any kind of collection, whatever it is, a set or a list, and allows actually to go through forward from the initial position or from the first element until the last element. For the list, we have also the option of list iterators that allows you to go either forward or backward. Okay, from the first element to the last element, or from the last element to the first element. And you can use dot next for going forward and dot previous for going backward. It only applies for the lists. Now,
What is the set?
hmm?
What is the set?
The set is a collection that does not contain duplicate values. You were absent yesterday? Yes, you should see the lecture of yesterday. Yeah. Okay. Okay, now I would like to explain to you what is the difference between linked list and ArrayList. So from the examples that we have done so far, it seems that they are exactly the same. Okay, we used exactly the same method for the linked list and also for the ArrayList. But actually they are different. So they are different in the way how they were constructed. So when you are going to do CS210, that is data structure, you will understand with more detail on how to build these data structures and what is the difference between both. But here I'm going to illustrate to you the difference internally, okay, how they are constructed. So for the array list, basically it's something like an array, okay? So you have here elements, an array. I'm going just to, okay? In the memory you have some elements, okay, that are stored in the memory, something like this. So it's an array list is similar to an array. It's a structure where you have elements. So and then you can use get methods in order to access a certain place into the memory. Okay. So for the array list, it has a different structure. Okay. So basically we have also elements, but these elements now, okay, they are connected with each other like a chain. Okay, so they are connected. Let me. Okay, so every element, it has a pointer to the next element. This is why we call it a linked list. There are links between the different elements. That is why we call them a linked list. Okay, and here. Okay, and also you have a link to the previous element, something like this. Okay, so in terms of structure, you will see in CS210 how to make this. This is very simple to do it. You can create a class. Okay, it has a value, it has next and previous. Next will point to an object, okay, and previous will point to an object, okay, which is the next value and the previous value. Okay, so now why we have these two different types of structures? Because now their performance will be different. Okay, it's true now in the linked list we have a get method, and we can add elements, we can remove elements, but the performance of adding an element, of removing an element, of returning an element at a certain index will be pretty much different. Okay, so let's, for example, see that we would like to add an element at the end. Okay, so I have a value here, 9, or I would like to add the values here between 1 and 7. So what's going to happen really? Okay, what is going to happen? Or let's see that I would like to add it here between 3 and 5. So what's going to happen? We're going to now allocate a space, an empty space. So here, that is empty. Okay, then copying all the values. So 7 becomes here. I will copy them. 1 become here, and 5 becomes here, and then I can put the value 9 here. صح ولا لا؟ Okay. So imagine that you have 1 million value, and then you want to add in the beginning. So you have to copy almost 1 million value. Every time you add a new value, you have to copy this number of values again. So it's really very time consuming. You see the problem? Okay. I want to add another value here. You have to create a space, copy all the values, and then put the new value again. When you have small number of elements, it doesn't matter. It's very small. But if you have very large number, okay, and sometimes you have arrays of million of values, especially if we have big data and so on, you know that we have a lot of data to analyze it, and this becomes a crucial problem. And this now, for example, in this case, the array list, the linked list will be much better and faster for adding elements. So now imagine that now I would like to add the element here. What it should be done?
Correct the links.
Yeah, all we need to do is to correct the links. Now, next of 3 becomes 9. Okay, and previous of 9 becomes 3. So this is one link, and then I will correct the link here as well. So previous of 5 becomes 9, and the next of 9 becomes 5. Okay, so you can see it's quite fast. Okay, so for example, now adding an element to a linked list in the beginning would be much faster than adding into an array list. And you can see the difference here. واضح? Okay, so this is why we have different type of structures. Now, when we use them into our code, they look exactly the same. Everything we did for array list, we can do it for the linked list. But now, in terms of performance, they are different. This is one of the cases where the performance of the linked list is better than the performance of array list. Now, if I want to add an element at the end, okay, the performance will be comparable. Will be almost the same. And here, if you want to add at the end, you don't need to copy, just put one value here, and here you're going to add one value with the new connections, and that's pretty much it, you know. So, but adding an element in the beginning, okay, the performance will be different. Okay, so now the linked list is better when adding elements in the beginning. The array list will be better when getting the elements. If I use the get method, okay, if I use the get method, it's faster with the array list, because you have only to go to the memory, right memory place, okay, and access the value that you want to. However, in the linked list, every time you do get, it's going to create a new iterator and go through all the elements until it reaches the desired index. Okay, and this is now, in terms of performance, the get of the array list will be faster than the get of the linked list. I can show you here a demonstration of this for the performance. Okay, performance test. Look at this program here. I create an array list and a linked list. And here the number of elements is 90,000. Huge number of elements. And then I'm going to do some operations. Okay, I will do one by one. Why? Okay. So the first experiment is adding an element at the end of the list. Okay, I will use add here and add to the linked list and add to the array list. And here I'm going to calculate the time. So before the loop I have t0, and after the loop I have t1, and then I will calculate t1 minus t0 to see the execution time. Okay? So in this case, array list and linked list, 24 and 11, 24 and 10. So adding an element at the end seems to be faster with the linked list. Now if I increase, it's the array list. I would say they are comparable. Okay, sometimes you can find one bigger than the other or the other one, but they are comparable. Okay. Now let's try to make add in the beginning of the list. Here. Look now, I do add at index 0 and add at index 0. So this means I would like to add in the beginning. This is similar to the example that I shown to you here. So who will be faster? The linked list. Look now at the difference. Duration of array list to add the head, 2 seconds. And here it's only 13 milliseconds. You see the difference? Okay, so it's huge. Now, if you want to know what to choose, whether an array list or a linked list, first of all, think what are the operations that you are going to do. If you have a lot of adding elements in the beginning of the list, in this case, linked list will be much better. Or if you want to access the element using get, in this case, we will see who is going to be better, and so on. So it depends on what you want to do. Okay, now getting an element from the list. Okay, getting an element from the list. So what I do here, every time I use get I, and I will use for the array list get I, and for the linked list get I as well. Okay, and I will see the difference in terms of time. It's still doing for get I in the linked list. Look how much time it's still doing. Only 3 milliseconds for the array list and a few seconds for the linked list. Okay, it's still running. Quite long. So you can see the difference. Okay, get I is not efficient if you do it with the linked list. It may take like 1 minute or 2 minutes for this very long array. Okay. So you can see now in terms of performance there is a difference. Although in terms of usage they look pretty much the same, but they are not. Now look, 90 seconds executing the get I element for an array of 180,000 elements. Okay, so now what to use? whether linked list or array list, will depend on what kind of operation you want to do on the list. Okay, so adding in the beginning, linked list will be much better. If you want to access the elements using get I, in this case, ArrayList will be much better. Okay, so that's all for today.